Hi, my name is Sam Malcolm, and in this quick video I'm going to show you what a hex code means. So if you've ever worked on web development, specifically the front end, build a user interface, that kind of thing, you've probably seen color represented with what's called a hex code. So basically they're written like, it starts with a hash, just like this, and it is a alphanumeric string that represents a color. So in this video I'm going to basically explain what this means. Most people think this is gibberish. A lot of people work with these, don't actually know what they mean. They just trust that this is going to represent the color that they want, and it is. So the first thing to know is that this is telling each channel of color what it wants. So on your computer screen or any digital display, at a microscopic level, your pixels are actually made up of small red, green, and blue lights. And this is telling the red, green, and blue light how much it wants to illuminate each color so that a group of pixels would represent a specific color. So this 6 character alphanumeric code is actually a group of 3 different numbers representing each channel. So these first 2 numbers represent the red channel, these second 2 numbers represent the green channel, and these third 2 numbers represent the blue channel. So it is telling how much red, how much green, and how much blue we want. So the first thing to understand about it is that it is a different counting system. It's what's called hexadecimal or base 16. So you and I are used to, in everyday life, using what's called base 10 or decimal. And that means each column has 10 different numbers available to it before you have to go to the next column. So here we would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we got to 9, we've run out, so we have to go to 0 again and put a 1 here. So you can tell a counting system what base it is by what 10 represents. So 10 here represents 10, whereas the 1, 0 in base 16 represents 16. The 1, 0 in binary, for example, represents 2. Binary is a base 2 counting system. So in hexadecimal, I'll do it up here, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then when we get to 9, we still have 6 characters, and that's where we get to the alphabet. Instead of numbers, we go A, B, C, D, E, F. Oh, that's a terrible F. And now we've run out of characters, so now we would have to do 0, 1. So this is 16 in a base 16 counting system. I'll explain why we use base 16 in a second, but it's important to understand the way that different counting systems work. So these are actually 3 2-column base 16 numbers. So 7A would be 7 in the 16s column, and A, which we know is 10, in the units column. And that would represent a number. So why is it base 16? Well, it's actually for your benefit. It's because it's easier to remember 6 characters than it is to remember 9 or 24. So you may have also seen color represented using the RGB method, which basically says you write RGB and then you write in parentheses 3 different colors or 3 different numbers from 0 to 255. Let's go 128 or something. This is telling the computer the same thing as this. This is a red channel, a green channel, and a blue channel, 0 to 255. This is saying the exact same thing, but it's using a base 16 counting system. So why is it 255 and why is it base 16? Well, it's because it maps down to bits more nicely. So a bit is a tiny bit of data that can be represented by 2 states. So in binary, it's 1 or 0. And we use that because it maps to the physical components of your computer, which can be also represented in 2 states as on or off. So you may have heard the term 8-bit color or 8 bits per channel. That means we have 8 bits of data per channel of color. So a bit, as I said, is 0 or 1, and a byte is actually a group of 8 bits. So I'm not going to go into why it's 8, that's probably a video for another time, but if I had, say, a byte of data, 0, 1, 1, 0, 0101, that is a collection of 8 bits. This is just a random array. So this could be represented by writing it this way, 6 characters, writing it this way, which is 9 characters, or writing it this way, which this is of course just one channel, which would be 24 characters. So it was chosen to use this to make it easier. So, but why does this map to this? Well, that's what I'll show you now. So to figure out the maximum number of numbers you have available in a counting system based on the number of columns, we need to take the number of different values, so in decimal it would be 10, and put it to the power of the number of columns. So here, if I had 2 columns of decimal, I would have 10 to the second, and that equals 100. So we have 100 different numbers in 2 columns of decimal counting. So we know that that's true because we have 00 all the way up to 99, which is 100 different numbers. So in base 16, we would do the same thing. We would have 16 different characters here. We have 2 columns in each channel to the second, and that equals 256. And as we know, we count 0, so that's why we have 0 to 255. So in binary, in a byte, or 8 bits, we would have 2 different values that can go into each column, and 8 different columns, and that is also equal to 256. So the reason why we use base 16 is because it maps directly to this, right? So we use base 16 because it maps to 8 bits per channel, and it's easy to remember the 9 numbers, and it's easy to remember the 24 different binary characters as well. And it also means that it's impossible to write an invalid number. So if we have this method, I could write 300 here, which is a valid decimal number, but it's an invalid color value for that channel. Whereas here, I can't write a number higher than FF in base 16. So therefore, you can't write an invalid number using the base 16 counting methods. So a few things to note. Let me just make some room here. So physics tells us that an equal number of red, green, and blue light is white. So if I had hashtag F, 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 that equals white. Because it is an equal number of red, green, and blue light, and it's as bright as it can be. If you have the same number in all 3 of these channels, it's going to be a shade of grey, and if you have 0 in all of these channels, it's the complete absence of light, which is black. So that's why 0, 0, 0, 0, 0, 0 is equal to black. So if I wanted to make a color more red, more green, or more blue, I would just simply increase the number in that specific channel. If I wanted to get the exact same color that I had, but I wanted it to be slightly lighter, I would increase every channel by the same factor. If I wanted to make it darker, I would decrease every channel by the same factor. Another interesting thing is if I have hashtag FFFF00, that is actually equal to yellow. So that is an equal number of red and green light, 0 blue light, to the maximum amount is pure yellow. Now, Vsauce has done a really good video on that. If you're watching this on sammichaelmedia.com, I'll put a link in the resources section below. If not, if you're on YouTube, have a Google for Vsauce yellow and you'll probably find it. It's really fascinating to watch. So hopefully you found this helpful. If you did, feel free to like, comment, and subscribe. Either way, thank you for watching it. And until next time, bye-bye. And I'm going to have to go rub this crap off my window. See ya.